For this week's second guided practice, we're taking a quantum leap in our programming skills. If you have read Chapter 2, you will notice that we added 2 additional control structures, both the decision structure as well as the repetition structure. So our if-else statements, we added those, and we added loops, while and do-while loops. And the example we're going to do will use the do-while loop. If you have the 8th edition of the Savage Text, on page 105 we will be doing number 12, the Babylonian algorithm for square roots. I'm going to create a new project. And I'm going to call it Babylonian square root, and I'll put the chapter 2-12. I was informed this week that the 8th edition of the Savage Text was sold out and the bookstore could only acquire the 9th edition of the Savage Text. They're pretty similar, but I did notice a little bit of reshuffling of the problems at the end of the chapters. So if you look at your screen, you should see the corresponding problem number and page for the 9th edition, for those of you who may have only been able to get the 9th edition of this Savage Text. I've created a folder already called Babylonian Square Root Chapter 2-12, corresponding with my project name. And as always, let's put our name at the top of the project as well as the date. And the file name. And a description. And as always, don't forget your using directive. We'll start by declaring our variables. If you notice in the problem description, the Babylonian algorithm starts with a guess, and they suggest you use half the number as your initial guess. Then they compute a value R. Then they compute the next guess using that value R. So I'm going to create several double variables here. N will be our number, our initial number that we're trying to find the square root of, and then we'll have R. And then notice that the guess is updated with the previous guess, and you can see at the bottom what they want you to do in this program is to have this loop approximate the square root to 1% of the previous guess. So the next guess, once it is within the range of 1% difference between the previous guess, then we want that loop to exit and then display that result. So I'm going to create 2 variables here, one called previous guess and then another called guess. And I'm making them all doubles. And next we will prompt the user for the number that we want to calculate the square root of. I'll read that number in to n. Next, I'm going to calculate the initial guess by assigning it the value of n over 2. And I'm going to go ahead and comment about that statement. Looking at the problem, instruction 2 tells you to compute R, and R, this is the value of n divided by your guess. Step 3 tells you to calculate the next guess by assigning it the value previous guess plus R divided by 2, that quantity. This is where I'm going to create a value for my previous guess. I'm going to assign previous guess the value of the current guess. That way I have a saved record of the previous guess. We have to do that if we want to be able to calculate whether or not we are within 1%, if our current guess is within 1% of the previous guess. Remember that all assignment statements are destructive, so if we perform instruction 3 and assign our value guess plus R quantity divided by 2 to the guess variable, then that will destroy the value that was stored in there of our previous guess. So that's why we need this second storage location, so that we preserve the value of the previous guess, and then we can compare that to the current guess. Once we're within 1%, then we will exit our loop, which we are about to write. So I'm going to create instruction 3 now and assign guess the value guess plus R quantity divided by 2. Now here's where the loop comes into play. On instruction 4, you see it says go back to step 2 for as many iterations as necessary, and we're going to do that until our guess is within 1% of the previous guess. So step 2 is where we assigned the value for R. So that's why I placed this space here. That's where our loop is going to begin, and this is where our loop will end. Most of the time you can interchange loops, do while and while loops. You just may have to do a little bit of shuffling with your statements. I recommend using a do while loop here, and that's what I'm going to do, because we need to perform these actions at least once, and that's kind of the defining factor. If you have statements in your loop that absolutely need to be executed at least once, then make it a do while loop as opposed to a while loop. The do while loop syntax, as you can see, starts with the word do, and I like to align my braces directly underneath the word do. Notice the statement do does not have a semicolon after it. And then the while keyword is placed after the closing brace, and it's usually placed just to the right of the closing brace on the same line. And then in parentheses, that is the statement that will determine whether the loop continues. So that statement may be the most difficult for you to come up with on your own. Up until this point, our programs have been pretty simple, and the arithmetic statements that you had to write were pretty intuitive. This one is going to take a little bit of mathematical expertise. If you recall from your mathematics courses, anytime you're trying to take a word problem and convert it into arithmetic statements, the word of is typically a multiplication statement. So if you read this statement that says, we want this loop to continue until guess is within 1% of the previous guess. Okay? So we want the difference between the two guesses, the difference between guess one, so that within statement is the one that's the tricky part there. We want the difference between the previous guess and the current guess to be within 1%, so we want it to be less than 1% of the previous guess. Now that's what we want it to be. So the loop has to continue as long as the difference between the previous guess and the current guess is greater than 1% of the previous guess. So that statement's going to look like this. Previous guess variable minus our current guess. And that order shouldn't really matter. You might have a negative or a positive value there. If we're just looking for a percentage difference, then we'll be in that. And for our engineering students, you should be well familiar with tolerance values. So our tolerance value here is 1%. So the difference between previous guess and guess, we want this loop to continue as long as that value is greater than 1%, and I'm going to type the leading 0 here in the decimal. It's not necessary, but it does help with reading. 1% of multiplication, our current guess, or actually previous guess, 1% of the previous guess. And the do while statement, which is has a semicolon at the end of that while statement. This is unique to the do while loop. Every other loop will not have a semicolon at the end of the parentheses. That also is true for our decision structures, if and else statements. Those lines do not have a semicolon. All that's left to do is display our result. So I'm going to say an approximation of the square root of, and then I'm going to display in our original number. That's always good in your statements to the user to give them that information, especially in this console programming. An approximation of the square root of, display the value in, is, and then display our result, which is going to be the current guess. So the value guess here. Run the program, save my CPP file. Let's run a few tests on this program. Let's check some numbers that we know the square root, and then maybe one or two that we don't. I'm going to start with the value 9, and we should get somewhere around 3. So you can see there an approximation of the square root of 9 is 3, and we've got a fairly precise approximation of 3 there, out to 5 decimal places. Let's try this program again with a larger number. I'm going to go with 121, and the square root should be 11. And there you can see we've got an approximation of the value 11. So the larger the number, the fewer decimal places of precision we will have, since we're looking at a percentage, or we're looking for a percentage of the previous guess. That looks pretty good. Let's do it one more time with some other value. Let's take a little bit larger number and see how our precision matches up. How about 5,280? Length of a mile. What's the square root of that? We get 72.6637. I'm just going to launch my calculator app and see how close we are. (72.663,608). So we've got at least 3 decimal points of precision. Not too bad. Okay, so that concludes our second guided practice for this week. And like I mentioned at the beginning of this video, this is a little bit of a quantum leap in programming skill. Now, learning the decision structure and repetition structure, learning how to create them, how to use them as far as syntax is concerned isn't too difficult, but the art form here in programming, which is a lifelong process, is being able to come up with these arithmetic statements that will calculate the values that you're looking for. And you know, this coming up with a statement like this, that might be a trial and error thing. For me, when I first wrote this program, I started with just the value guess here, and of course that didn't give me a very close value, and I thought, okay, that's right, the statement within there meant that I needed the difference between the two, and so I expanded on that. So don't get frustrated in your self-practice if the algorithms don't just pop into your head automatically. That's not what programming is. This field is one in which you have to grind through some of these problems, and don't be afraid to just put something in there and run it and see if you're anywhere close. And that's what the debugging process is all about. Tightening up your algorithms so that your program does exactly what it needs to. Happy programming, and this is J Money reminding you to know yourself.